To make a good recording, I will skip this part and do the announcement again so we can make a beautiful recording this time. As you can see, Kevin Martens is talking about a modern manifest of cyberspace, and we know him from the Hacking at Random as well as the founding of the hackerspace in Den Haag. And he will give us a short rundown of the history of the cyberspace and show possibilities and how we can make its future look bright. So give him a warm applause, and now we can start.
Well, thank you. So this is about a dream I've had for quite a while now, and seeing what's going on currently in hackerspaces and the hacker scene globally. I think it's about time that the dream is going to become a reality. But before I go into that, I made some slides. I'm not a big fan of slides, so I didn't make them too boring. But just so that you know, I'm just not rambling, but actually working toward a point. I put some of the structure on there. Indeed, I will look a bit at the history. How did the internet come about? I mean, most of it is probably already known to you, but maybe not. Then current affairs, because there's some dark clouds looming, not just outside, but also for the internet. And then I will look ahead at how to overcome all that. And I want to start a bit with the history of the internet, which for me sort of starts with the telegraph. I don't know if you know this little booklet, the Victorian internet. Actually, they started really, really long ago already. This is like the 17th century. I mean, you have to sort of think that away, because, but anyway, this is a telegraph, a semaphore telegraph, and it was used in the 17th century as a, well, basically as a relaying network. There would be several stations of these, and people with binoculars would be looking out to the next pole, and then, well, you could make patterns with the shutters. And well, that was a way for them to communicate. So they had all these code books, and you can imagine the distance is a problem with this system, because if you have bad weather, yeah, it's going to be difficult. So what they did, they set up a whole network of towers. This is actually somewhere in the UK, I think. Yeah, so that's quite an extensive network already. And during the 18th century, this also moved forward, and you would see very big. Yeah, of these networks everywhere. This is one a bit closer to where we are now. It's not in Germany exactly, but yeah, you get the idea. I mean, this is just one line. At some points they would branch off, and it was actually quite an efficient way of well, getting information across. So you have to imagine that the points between these are 20 kilometers or something. So of course then we moved on, we got radio, we got electronics, so we replaced the visual lines with cables, or at the beginning first radio. Of course with radio you again have the same problem of atmospheric influences. So yeah, electronic cables, that gained a lot of traction. One important thing there was the first transatlantic cables between the United States and the UK, and yeah, that was really a breakthrough, because you could just within seconds get a message from the States to the UK. At first they experimented a bit with DC current over the cables, which sucked, and it almost failed and never became anything until they used AC, because well, that's better for sending electricity over long distances. Yeah, so that worked out. At first you had all these point-to-point links. There would be a telegraph office here and a telegraph office there, and they would just communicate among each other on relay networks. But at some point they just hooked up all the cables to one node, so they could all chat with each other. And actually they did chat with each other, because the early telegraph operators, they sort of developed a protocol akin to what we now have IRC. And well, if the network was idle, they would just tap and chat about family and friends, and I don't know. So that's I think that's quite funny, that wasting time on IRC was already something big then. Of course, later we had the telex machines. Actually, if you want to see one, I don't know if anyone has never seen one, they're quite old, but they have this tape where you can, they make holes in the tape and you can store that and replay it. There's some in the hardware hacking tent. There's an actual telex that they hooked up to an IRC channel. Yeah, so that's when there was already a point-to-point connection. And I think that's also one of the things that then became more popular. We went to terminals and everything. also point-to-point. You hook up one line to a mainframe. Yeah, so it started out with things like these. This is a deck writer. That's basically a printer with a keyboard, and you can use it as a teletype. I actually have one of these. The other one is well, a more modern terminal with a screen and everything. Yeah, so that was great. You could put a terminal, I don't know, hundreds of miles away from where your computer is and just work at home and everything. Well, the disadvantage, of course, still was you have to have a physical line from you to the mainframe, and that kind of sucks, especially if you work at two institutes or whatever. You have two of these terminals. And at some point, this guy, Licklider is his name, he had 3 terminals to 3 different research institutes. So yeah, he was typing on one terminal, someone said something to him, and then he had to type it in the other terminal, and that's not a good way to have a discussion or whatever, or share information. So yeah, that was an itch to scratch. He began thinking, yeah, this guy then, well, that's Cheyenne Mountain, big US Army site where he worked. He worked at the IPTO, the Information Processing Techniques Office, and he was thinking about something cool. He called that the Intergalactic Computer Network. And that basically became the first incarnation of the internet as we know it, like the ARPANET. So at first it just connected these three PCs, but one important improvement here was circuit-based networking. So now packet switch network. The terminals, it's all circuit-based. You have one circuit from your terminal to your mainframe, and that's it. With packet switched networks, well, you know all this. You just have one big network, and you throw in a packet, and it comes out at the other end, and it doesn't really matter where you want to go. Yeah, so in 1968, they started to put out a bid. Well, who's going to build this? And most of the tech companies said, "Oh, that's a crazy idea. That's never going to work. Let's not do that. That's going to suck." So, well, they did it anyway. They found a company to build it. So in '69, they had 4 nodes. It expanded a bit, and it's actually quite fun to do a bit of archaeology. Just look at RFCs and start at RFC 1 and read it, and then move to the next one and the next one. And I mean, there's whole plans in there about how to build it up, and it's quite. Some are actually quite humorous as well. So a sidestep is maybe AloaNet, which was also introduced around this time, which is basically the first wireless networking. Which used 2 frequencies, one for the data and one for the flow control. Yeah, so ARPANET, in '69 we had the first telnet sessions, I think. '71 we had the first email, so that's also FTP, by the way, so that's really saying that this is really old and deprecated technology. Later, '73, there became international connections. You can see a hint of that here to Norway, the UK, where they were also developing packet switch networks. Most notably, there was, where is it? Mark I was a UK-based packet switch network, which also became incorporated in the ARPANET. And what you see is that the whole building of this internet, okay, so it was a defense project, yet it was not construed for defense purposes. It was exploration, academic interest, research. That's why it was built, and that's quite interesting. You can also, I mean, there was sort of an idealistic view, like freedom of information, and once we get everyone connected, the world will be a better place. Well, it turned out it didn't. Actually, at some point, the ARPANET expanded with some other networks, CSNet notably, NSFNet, which was a network of supercomputers in the US. And actually, NSFNet was one of the last academic networks to drop their restrictions on commercial uses of the internet. And once that was done, yeah, so we get the 90s, World Wide Web, masses, and commerce. So that's when trouble in paradise starts. I mean, there's a lot going on at the moment that's eating away that idealistic view, the freedom of information, the free flow of information. For one, there's the commercial entities, well, the people behind ACTA, of course. And they fear it for the threat to their current business models. I mean, they are used to shifting boxes and everything. That's not going to work if you can just copy the product. But the scary thing about this, they are so fierce in protecting it that Hollywood actually is trying to get into the lawmaking process all over. I mean, Europe and all the other countries that are in the ACTA negotiations, they just listen to industry and try to. It's like pushing laws. You can get disconnected without fair trial just because the content industry says there might be something going on, and that's actually well, kind of scary. Recently there was a EU Parliament report which analyzed the ACTA. It was of course construed in secret in back offices and all, unbeknown to everyone. And well, the report was quite harsh because, well, I'm just going to maybe quote it. It says, so this is by the EU Parliament. It's a really long report, but this paragraph sort of sums it up. So there are substantive areas of concern, covered a range of issues, including the potential negative effect of ACTA on fundamental human freedoms and privacy, the possibility of requiring cutoff of internet access to consumers that infringe the agreement, imposing liability on internet service provider that carry content that infringes the agreement, and the potential negative effect of ACTA on access to medicines in Europe and in third countries. So that's not too much with the internet, but that's also one of the negative things of this. But yeah, that's kind of scary that the content industry is imposing their laws basically upon the states. So examples of these are the 3-4 strikes you're out things, the suing of ISPs who are just transferring the content, and well, there's also all kinds of voluntary cooperations between ISPs and the content industry, where they just, well, even unknown to the customers or whatever, they make agreements. So, for example, in the UK, there was an agreement between certain companies to do deep packet inspection, so they could hunt down the IP offenders. The USA is actually also working on that. So they are, yeah, that's one thing. They're also using it to gain all kinds of information about us, right? Where we are going, where we want to, what we are looking for, what we are reading. I think it's kind of scary because their only goal is making money. I mean, I'm not saying that that is a bad thing, but if that's the only goal they have, then I don't think they are doing what's best for me, but only what's best for their income. Yeah, which also is where the other, actually, the other actor comes in, the state. They are increasingly looking for ways to, well, surveil us, make sure we only read information that we are supposed to read, which is with the current paradigm. For example, data retention is really bad, it's going on. They just store everything, just in case of an investigation, so they can pull up your data, maybe see if you were near the scene of the murder, I don't know what. I mean, and they say it's just in case of an investigation. We store it and we don't do anything with it until we have a suspicion about you. Well, meanwhile, they do send, in the Netherlands, for example, the police sends text messages to, well, all the people who basically were at a certain point in time, at a certain location where something happened. And that's, yeah, that's, I mean, if you have no suspicion, why should you be texted like, please come to the police office if you were there, and you know, that's kind of scary as well. In Europe, I think we basically lost the fight, but I'm not too sure on the latest on that, because it's always, it's never, we make a decision and it is so. I mean, it's always a constant flux. USA currently also are discussing this. They go a bit further. The data that is stored should also be available to example, for example, to the RIAA, which is the well, the record industry. Or actually, like a lawyer that's like a divorce lawyer, he also gets access to data if that is relevant for the case. Let me see. I'm not answering. Oh well. So that's, yeah, that.
You will enjoy plenty of Italian grappa and Italian gasoline.
Okay. Well, there's a party at the Italian village tonight. Now, where was I? Yeah, there's also the kill switch. I mean, what's that about? It's impossible, right? We think, at least we like to think. But if you really think, there's only I don't know, in the Netherlands, for example, 3 or 4 key locations that you have to have cooperation for if you want to just switch off the internet. Sure, there will be some smaller links left, but if you really want to cut off a society, I think that can be done. And then there's also censorship, of course. You think it's only in China? Well, that's not the case. For example, my own blog at some point became inaccessible from City Hall. I was quite active in local politics at the time. We made a funny site during a campaign, and apparently that had something related to drugs in it. So the whole site and the whole server, the whole IP was shut down. So including the site of a member of council that I was hosting incidentally. So that also shows that the whole censorship thing, you block one thing, but you block more than you want to. Australia, that's where I got the picture from. There was a photographer, Hansen. It was a bit controversial, but he had to take off all his pictures in Australia because, well, the state apparently decided they were not suitable to watch, even though there was no law being broken. I mean, yeah, there's Sweden. There has been an order in 2002, I think, that some sites should be blocked. Turkey and YouTube, France and gambling sites. I mean, you are not supposed to see gambling sites in France, so, well, has to be cut off. And then America, land of the free. They have really no government censorship, but I think that's mostly because corporations there sort of are the government. You see a lot of suing and DMCA, the Digital Millennium Copyright Act, where an IP owner can just say, well, you are infringing on my IP, take it down or I will take legal actions. Even though it's not the case, an ISP will readily listen to that, because if they don't, they might get hit very hard by the content industry. So it's sort of an involuntary mutual agreement that if the content industry says we want that down, then they take it down without question. Because if they start asking questions, they might get a hard time. So that's another example. I mean, luckily enough, they're all too stupid to realize how the internet works, of course, so they never managed to actually block anything because there's dozens of ways around it. But I guess it's just a matter of time before they catch up, and then, yeah. And it's still an inconvenience, of course, to the casual user. Actually, this all is not new. In 1996, there was the Telecommunications Reform Act, which prompted the writing of the Declaration of the Independence of Cyberspace, in which Barlow from the EFF used quite strong language, saying, hey, cyberspace is our turf, we know what can be done and what can't be done here, so leave your rules and your borders out of it, because they don't apply to us. And I sort of think that that's a nice thing to think. Yet, I think Barlow failed to realize one thing, and that's that the infrastructure is actually not ours. I mean, it's the government who built the internet in the first place in the States, and then it's commerce that expanded it to be really a worldwide big network. But we the people, we have not participated in that. So the terms of access, the terms of how things have been set by these big organizations who, well, don't always have our interest in mind. So, yeah, but we stood by and let it happen, which is kind of weird actually, because I think we all do the work. I mean, there's probably a lot of sysadmins in the room, or people that work at ISPs for the government, or maybe even the content industry. So yeah, I think we failed to live up to Barlow's declaration, and I think it's time for a change. Now, there's a couple of movements that are going on. I mean, some people are saying, let's go underground. We put, Jesus, I have too much technology. Battery is low. Yeah, so we go with encryption, HTTPS, PGP. Of course, that only works if everything is encrypted. And as it is right now, there's a lot not encrypted. So if you use encryption, you're automatically, well, suspect, because you maybe have something to hide. Good way in it, if you to encrypt everything, is dark nets. Well, there's plenty of examples of these. You've got your DN42, which is a network between hackerspaces that uses OpenVPN and other VPN, and it just creates a network that's invisible to anyone not in the hackerspaces, and it's just peering between people. There's Chaos VPN and Agora Link, which is sort of the same, and they were all like decentralized. There is no central organization like with the internet where you have ICANN who assigns numbers and names. And that makes it more resilient and more, I think, there's no one who can set the terms. And that works better than I think. There's things as Freenet where you can put content in it, it's distributed, encrypted. So if your computer goes down, the content is still there. Of course, there's also things like Tor, which provides basically untraceable routing, so no one can track you down. There's I2P, which is I think also a nice peer-to-peer network where you can again put content. It's more geared toward hidden services actually. So whereas Tor is more about, well, I want to go to the real internet without people knowing who I am. I think P2P is more like let's leave the real internet behind and let's put everything in an encrypted environment and distribute it. But I think these are workarounds at best. I said it, the infrastructure is not ours. If people think, hey, I don't want this, they just, I don't know, check out what's going on. And if it's not something they know, if it's encrypted, they don't know what's in there. So they say, well, then I'm not going to pass it through. I will just allow you to go to these sites. Yeah. And already many actually public Wi-Fi blocks HTTPS traffic in my experience, which is kind of annoying because that's usually the last escape you have. Yeah, so another thing that's going on is that people are looking to go back to the roots, you know, the good old sneaker net, where you just take data under your arm and walk with it. A recent initiative was, for example, the terabyte dinner device. You have a nice dinner with friends, you all bring a hard disk, you plug it into a machine, you go eat, and when you're done, all the content is synchronized, and you go home and you have, well, whatever your friends were wanting to give you. Yeah, for example, conferences like these, I mean, there's a shitload of FTP servers here, and people are copying it. Well, you get much higher data rates anyway. I mean, if you take a 2 terabyte disk on a plane say, Toronto from here, that's 58 megabytes per second actually, with a bit of latency, of course, but that's quite awesome. Recently, we've seen the dead drops, where there's just USB sticks in walls. You can go there, put the information on there, and someone else can get it off. Personally, I find it a bit scary, but it's one of the things you can do. And really nice thing that's illustrated by this. I don't know, does anyone recognize it? I know I've been on this transport system, but I don't know what city it is anymore. So, but what they're doing, they put little notes on trams, metros, buses, and they use kinetic energy to keep charge. And whenever 2 buses or trams or whatever pass each other, they will exchange data. So if you're at one end of the city and line 3 is coming by, you send some data with the tram and it goes to the central station. There's lots of trams there, and well, someone else at the other end of the city living near line 9, he gets its message. It's a nice novel way. They're actually building this, so that's, I don't know, I think that's kind of cool. Well, and there's a whole other realm of solutions. One that I personally find really promising. I've got a few examples here of people who just built their own infrastructure with wireless. Left is an example of Vrijfunk, and right is actually Wireless Belgium. And they started as Wireless Antwerp. So somewhere here under this thing, this is Antwerp. They started with a city, but pretty soon they expanded to Brussels. Well, before you know, they were all over like the north of Belgium, and we're now even going into the Netherlands. So it's it was Wireless Antwerp, it's now Wireless Belgium, and pretty soon it's going to be Wireless Luxembourg, I guess, Wireless Benelux, I think, for Belgium, Netherlands, and Luxembourg. And yeah, I think that's really a future, because these nodes are relatively inexpensive. You can just put them everywhere, and well, you don't have to put infrastructure there. And mind you, all these nodes are managed by hobbyists, and it really works great. I mean, it uses traditional routing protocols. It's not mesh networking yet. which is another direction. Mesh networking is actually where you drop a node without configuration in the network, and we'll figure out where it is in the network topology. And that's of course really a really strong way to grow a network. You just throw away the access points. I'm simplifying here, but you wait until they find each other, and then you can just route traffic over it, and that's I think even better. I mean, if some links go down, it will heal. So one of the initiatives that's currently going on is the Freedom Box, which is Eben Moglen's project, I think, and they're building these boxes in such a way that everyone, like my mom and my dad or my grandmother, can just put it in her home and read her email, but have encrypted networks. And the idea of this is that it will grow. When more and more people use it, it becomes a stronger infrastructure. Of course, there is a lot of mesh networking going on already, and I think there's quite a few people at the camp who are involved in the battle mesh happenings. I think that's once every year, and they just try out all the mesh networking routing protocols, discovery protocols. Yeah, and that's really important. Other community-operated initiatives. This is a map of I don't know how your topology is, but with the arrow, that's Barcelona actually. So this is the coast of Spain, the east coast. And yeah, I mean, the green lines are connections, nodes, and they're getting, yeah, they have a blob there, and this is all with wireless. They've been putting their own fiber in rural areas that have been left behind by the commercial companies because, well, there's not much money there to make. And this is all community driven. It's peer-to-peer agreements. So if I'm already in Wi-Fi.net and someone else wants it to be in there as well, we just make an agreement between us, and that's it. There's no like central committee that has to approve it. Of course, that gives us also a lot of challenges, but I mean, yeah, there's even more. Actually, they have 14,000 nodes now. That's quite impressive, I think. So this, I think, is the future of networking, where we just make agreements among ourselves and yeah, build things ourselves. One interesting, well, that I will shortly touch upon is a project that's, I think it's called Greyfi. I couldn't find it back anymore. I read something about it where they just use channel hopping, but with a very broad spectrum. You just scan all the frequencies and, oh, this one is free at the moment, let's use that. And as soon as you see that someone else is going to use it, you just go off and take another frequency that's available. Also, actually in the Netherlands, some guys are now working on setting up their own GSM provider because they're kind of fed up with the current providers, the deep packet inspection, the limiting of bandwidth to sites that do not pay to the providers. And that's, I mean, there's a lot going on in taking back the infrastructure. Yeah. But my thing is, we're not really talking. I mean, Wi-Fi.net is great, Wireless Belgium is great. There's no talk, no plan to connect all these networks together, which is, I think, quite important for reclaiming cyberspace, basically. And one global grassroots network that we can use to communicate. And yeah, so that's a true internet. Many networks interoperating. There's lots of challenges, of course. There's bandwidth. I mean, you can't scale a mesh network really because there's as you get more nodes, the bandwidth increases. The bandwidth demand increases with a higher rate than the bandwidth that's becoming available by adding new nodes. I mean, some solution to that, I think, and I think we really should go there, is leave the idea that information is at one point and we all go there and request it. The information should be everywhere and close to the people who use it. Yeah, so there's some challenges there. There's a lot of work done on that already. Freenet is one. There's, I mean, there's a problem. If it's everywhere, how do you know if it's the real information? But yeah, those are things that cryptographic experts are working on, luckily. Yeah, and there's another thing, bridging the continents. How will we do that? That's kind of difficult, right? Because there's now a whole lot of fiber cables everywhere. Luckily, at this camp, we started the hackerspace space program, which is, I think, a logical thing to do. I mean, recently I went on a tour of hackerspaces in the United States, and I ended up in Alabama at Makers Local, and well, they just had this on the whiteboard. They were already planning building rockets. Actually, they are quite near to the center where the United States rockets are mostly designed, but I mean, these guys are thinking about putting satellites in the air, and there's the whole CubeSat movement. There's been radio amateurs that are actually thinking about, actually have been putting relay satellites in orbit as well. And prices for this are not astronomical anymore. I mean, it's within reach of a small group of people to gather this kind of money and just shoot things up the air and play with it and maybe get some reliable reliable links there. And I think for me personally that is something we should do, because, well, if we don't bridge the continents, if we still have to use the fiber cables that are there, yeah, that's not going to work, I think. So yeah, I mean, that's a lot. I think that's, I mean, we have to start small, of course. I'm saying we just launched some satellites. So there's this thing, the Free Network Foundation, who's also really thinking about this. I think Isaac is in the room here. He has the same dream as me. We just met at the conference actually, but he put down 5 freedoms analogous to the 5 freedoms in free software. Yeah, and basically the first is that access to the network without tariff. That means if I want access to the network, of course, there's some money involved. Someone has to pay for the electricity and everything. But why should I then also pay 80% of the price just for profits? That doesn't make sense. So doing this ourselves, just hooking up devices in our own power grid, we pay a small amount for the power, but we can hook into the mesh and transmit. The second freedom is to transmit bits from peer-to-peer without interference, interception, or censorship. Well, that's kind of a no-brainer to me. We should have that. The second is to determine where one's bits are stored. This is one I think I would be able to discuss about for hours, the finer points of this. Yeah, and the third one is also an important one. Maintain anonymity or be able to present a unique, trusted identity. I mean, if you want to be anonymous, it should be possible, but it should also be possible to make sure that the party at the other end really knows it's you. And of course, technologies exist for that. And part of the projects that I presented and part of my dream is that these things are really an integral part of the network instead of add-ons on all the protocols that were designed in a time that everyone trusted each other. So yeah, and the last one is to basically determine the parties to whom, yeah, so who you give your bits. That's a tricky one, and that's really difficult to implement. But it gives an idea of the kind of the kind of things we have to think about, in my opinion, when we are going to, well, just redesign the internet, basically. Let's be ambitious here. Well, I say we should start small, of course. There's, oh, I'm missing a slide here. That's okay. Free Network Foundation also has these 5 steps on the site, which I think really apply. So the first step, I think we already have that going, is internet co-ops, where people just share an internet connection. From there, we progress to a stage where people will not only share an internet connection, but also communicate amongst each other. It's called the digital village step in here, and it's where like a smaller area just meshes the network that they share, and yeah, expand its reach. Next thing is to connect all these disparate initiatives, and I think that we're somewhere between the previous step and this one, so that it becomes a larger internet. And at first, we will have to use existing infrastructure, I think, tunnels, VPNs, etc. But yeah, the next logical step is to indeed build our own backbones and, as I said, launch satellites, do what Griffy.net is, just put in fiber, and yeah, and then the fifth step is quite an important one as well. Once this is there, I mean, access to the network should also be a human right, because, well, you increasingly need it to even participate. You can't even communicate with your government anymore without internet. So yeah, it makes sense to have that. I'm saying small, well, forget that. We're already not small anymore. There's Freifunk, Wireless Belgium, Griffy. I mean, it's rolling. So yeah, how it's going to end up. It won't be one technology, I think. There's lots of technologies here. There's ham radio, there's bouncing signals of the moon or the ionosphere. They all have a role in forming this new internet. And the great thing about not focusing on one single technology, if something happens, chances are that at least one of the methods still is available to communicate, whether it's a natural disaster or a government interfering. The chances are that it survives are higher, and that's also important, I think, especially in disaster. I mean, the same hackerspace I was struck by big tornadoes recently, and well, it was a mess, and everything was down, phones, internet. But it was the ham radio operators that managed to get links up and communicate between the rescue efforts. So that goes to show that it's good to foster all of these technologies. A lot of it is, of course, about decentralizing. I already said that. We do not have one institute that will determine, set the terms, define all the numbers and assign them to parties. A decentralized DNS, I think it's already there. There's several initiatives that do that. Decentralized search engines. There's, for example, Yachi, who does exactly that. They have a distributed network that crawls sites and indexes them and stores them distributed. So if a few nodes go down, it still works. Yeah, and that also decreases the grip that malicious elements can have on the network. Which is, I think, essential to going on with this. And I think that's sort of the end of it. Yeah, so I think we learned a lot in the, 30, 40 years? When we first built the internet and expanded it. I mean, I don't know how the internet that I envision will be exactly. I have an inkling, I mean, I have some ideas. But I think it's mostly about looking what's out there already and getting people to talk together. I mean, I know we together are a smart bunch indeed. Well, and when a smart bunch puts their minds to it, well, things happen and things happen fast. Look at the internet. It's a relatively short time, but it has totally conquered the world. So, yeah, thanks for listening to this obituary of the old internet. And, well, as far as I'm concerned, the internet is dead. Long live the internet.
Since you were quite fast, we still have some time for questions. So, do we have any here? Please come to the microphone.
There is a question from the IRC channel. The question is from... Sorry, I have to search it. From WebMind, and he wanted to know the name of the Antwerp project for wirelessantwerpen.be because it's outdated, and he want to know which project is the real project. I can write.
Yeah. Oh. So that's wirelessantwerpen.be actually. So you can put that in your, yeah, it is. I'll show you afterwards. Actually, this URL, go here, that should be dfnf.org, just so you know. So you can also go to nodedb.wirelessantwerpen.be. Yeah.
Any other questions?
You did talk about an attractive solution for wireless mesh networking that your mother or your grandmother could buy. Is it already existing? What was the name of it?
That's the Freedom Box project. It is not currently existing. There has been a lot of time put into designing the whole project, the whole, yeah, and a lot of fighting, of course, what distribution should we base it on, and but it's yeah, it's a Freedom Box. If you Google for that, you'll probably find it. And they are a bit sparse with giving out news about it, but from what I hear, it is going well, and people are actually starting some development on that front as well. It's about a year or 2 years ago that the idea was launched even. So yeah.
Another question from the IRC channel. Is there a centralized point where all information regarding this new internet is collected?
Yeah, it's sort of antithetical, right? To have a central point where all this information is collected. But indeed, the URL that should be up there, that's DFNF, the Free Network Foundation.org. And there's a mailing list there you can sign up. There's a wiki where we intend to, kick off this project. Just get people talking and see what we can accomplish in linking things together and move this whole dream that we have forward. So that's, dfnf.org. And mind you, that's not going to be an organization that says you have to use this technology if you want to. It's a forum, it's a platform to bring people and initiatives together, because that's I think we have critical mass. It just needs a small push and really great things will happen, I think.